Hello students, in this video we are going to learn how to solve quadratic equation using Excel VBA. I have a code written which actually solves a quadratic equation with a function written in VBA. It is assumed that you know what is a quadratic equation and how it is being solved using this formula. Now the maximum power of this quadratic equation for x is 2 and the coefficient for x square is 6, coefficient of x is minus 17 and coefficient of x to the power 0 or the constant coefficient is 12 here and it is equated with 0. Now in general form this 6 is nothing but the coefficient a, this is coefficient b and this is coefficient c. Now if we plug those values here we get the value of x for which this equation satisfies. Now here as we see we have plus minus, it means quadratic equation can have maximum two roots or two solutions. Now for example in a particular equation say a is 2, b is 3 and c is 1. So the equation is 2 to the power x square plus 3x plus 1 equal to 0. If we solve this equation we get two roots as one is 0 minus 0.5 and one is minus 1 and both are real solution. Now how this is evaluated? So this solve quadratic equation function takes ABC as input and these two root 1 and root 2 are basically returned from this function and this is the message. Now this root 1 and root 2 are printed here in the immediate window. Now if we look into this function, so this function actually this function is written considering this formula. So whatever is within the square root is called the discriminant. So the discriminant is calculated, this part. Now if it is less than 0 the roots are actually complex which is set into the message, and if it is not less than 0 then it is a real. Now in both cases the roots are calculated using those formulas and the function returns the status whether it is successful or not. If a is 0 in that case it's not a quadratic equation, it's a linear equation basically. In that case this function returns false because it does not solve the quadratic equation. So if it returns false it just prints the message that it is not a quadratic equation. Otherwise it means if it is the status is true, it means it is successfully able to solve the quadratic equation either with complex root or real roots. It is then printed here. Now to try different values we have to manually change the value, right, and try it again. So in that case we see we are getting complex number basically, right, complex conjugate numbers we are getting. So what we can do, we can actually, instead of changing the values in the program, we can take the values from the Excel itself and run the program. So in the previous case, let me delete it and run it again. So it is taking the values from here. We can check if we change the values here, it solves the equation and gives new values. Okay. Now these values are not really understandable or the meaning is not understood very well. So and changing those values manually is not so easy. So what we can do, we can have the sliders. As soon as we change the slider the roots are printed here also, as well as these values are, this x1 and x2 is the actually basically the roots, those are printed here also. As you can change any of the slider value, it recalculates the quadratic equation and prints the roots here. Now this is just the numbers, either real or complex is printed here. But what is actually a root? What is the meaning of a root? Now if we start an AutoCAD, it means this program always search for a uh, running AutoCAD instance. If running AutoCAD instance is there, let's see how it handles that. Suppose we have the coordinate system XY coordinate axis are drawn already. Okay. Now if we just change the values here, we can see it actually draws the graph in the AutoCAD. Now still we see complex number because this graph does not cut the x-axis. So let's see if we can change the graph and get a real solution. Now as we see, we can find two real solution, 0 and -1. That's why these two roots are plotted here. We can also see. Now again, changing these values with these sliders in the Excel is not so much easy. So what we can do, there we can have a user form, right? Now this user form, if you can change the value, if you can change the value from here, it also changes the value here and the sliders and recalculates the roots. It shows in the Excel sheet as well as here. Now for example, as you can see, if you change the value of ABC using these sliders, it draws the graph with polyline, and it also shows the roots here. Roots are basically the values of x for which the y values is 0. Y value 0 means it actually intersect the x-axis, right? So for these two values it is intersecting. So we have two real roots because it is actually intersecting the real number line. But for some reason, for example, now it is not intersecting. It means it has no real roots. It has complex roots, but it cannot be plotted here because it is not intersecting, right? So for such scenarios, we can see, so for different values of ABC, now this is a case where it becomes a linear equation, and because a is 0, when a is 0, now this b is, if we change the b, the slopes are changing, so the line is actually rotating, right? Its slopes are changing. Now keeping the slope same, if we change the c is the actually y-intercept, so it just moves up and down. So a quadratic equation become a linear equation why when the a is 0, but when the a is not 0, it becomes a quadratic equation. And at different combination of ABC, either we have two real roots or one single real root or two complex root, right? And we can see here, so in this example we have seen how Excel VBA can drive AutoCAD. Now all the calculation is done in VBA, uh, and we have connected AutoCAD with Excel using ActiveX connection. In some future video, I will show how easily you can actually connect AutoCAD and Excel programmatically, and how to run AutoCAD VBA sample code from Excel VBA very easily. Thank you.